Hello there again. I just want to give you an update on my diversions, on my ignoring one that I said I was going to do. I got curious about that thing, and I had a pretty good idea of what was going on. So I thought, well, this thing draws that example 4 or whatever it was, draws a cylinder, right? I mean, it looks like a cup, but it's just a cylinder. In fact, the code for creating the cylinder is right here. Okay. Now the way that this works, this is now these colors. I could set them both to white. It just has some effect on the I don't know. It just has some kind of a strange effect on the colorizing of the texture. If you could draw a cylinder, how can I do this? Paint, maybe? It's too long to open up Paint Shop Pro. Now I can draw, I think, I guess. Yeah. Okay, now looking at the code. What this thing is attempting to do is to create what they call a triangle strip, which is different from a triangle list. That forms a cylinder. Okay. Now here's their algorithm. As you can see, that at I equals 0, the first, a triangle strip is a bunch of triangles, but it's a strip in the sense that some of the triangles share sides with each other. So the first position is cos and sine of theta in x and z and y plus or minus 1. Well, the first vertex is at minus 1. So if we had like, well, dear, better than that. We need somebody to draw a straight line. Next one. Line. Okay. X. No, Y, sorry. Like you learned in school. X, and now usually Z we think of as coming out this way. And then going off, into the background. Okay, so suppose theta equals 0, then we get 0 for x, so that's here, and y equals 1. So, yeah, no, yeah. Z equals 1. Now, depending on the way this goes, in or out, let's say it's here. I draw a dot. There's the first point. Okay. Oh, yeah, and y equals minus 1. That's not our first point. Here's y. Minus 1 is up here. We need a color, maybe. Okay. There's point 1. The next point is the same x and z, but y equals minus is plus 1. So that's down here. Get that in a line. So the other point is down here. Okay, then theta increases. So now x gains a little, y loses a little, z loses a little, and so we're moving around in a circle here. And so the next point is going to be somewhere like here. See? Now I need this thing. So vertex 1, vertex 2, vertex 3. We're done with that one. Okay. And there's 2 each time. So the next one will be that one's done. How do I say it's done? So therefore the next one's going to be here. Okay, well, a little bit more. But we're moving around in a circle. That circle is centered on the origin. It's hard to get it. Something centered on the origin. And the maximum value being here. Okay, well, it's going around the circle. Okay, so it's that, and then the next one is going to be the next point is going to be here, right? And then here, and so on. Y going up and down, all the way around, which makes a circle, a real circle. Here with two ends, and these vertices go along around the circle, and that forms a cylinder of triangles, all going around here. It's difficult to imagine, but not so hard. Now, at each point in the in this array of triangles. It's making a strip of triangles. Two coordinates are given in what they call the texture space. Okay. Now, texture space is a are the xy coordinates of a texture or image of some sort. Okay. And the 0, 0 in the UV space would be, let's say the upper left corner, and 1, 1 would be the bottom right corner. Now this thing here is giving texture coordinates for each of these positions. Now the first one with y equals 0 is u equals 0 and v equals 1. So if that was a box, so that top first point corresponds with texture coordinate x equals 0 and y equals 1. So I don't know, you'd think it'd be upside down. It might be. And the bottom one is 0, 0. Right? So the y coordinate of the texture is in correspondence with this, like 1 corresponds with y equals 0 for the texture, and minus 1 corresponds with y equals 1 for the texture for each point. So the texture, at least as far as the y coordinate is concerned, is mapped completely from the top of the cylinder to the bottom. Now, as it's going around the circle, the x coordinate of the texture starts. Now it's the same for both of these vertices. Turns out. So it's starting, and it's a straight line, so it makes some sense that the x coordinate of the texture at any given angle in the cylinder is the same. But as you go through the entire circle, it goes from 0 up to, it should go to 1. Float I, which goes up to 49. 49 over 49 is 1. So at the end, this is 1, 1, and this is 1, 0. And that maps for each of these vertices a corresponding position in the texture. Alright? Now, and that's a cylinder with a texture. You don't have to use a texture. So I had this idea. I came up with this idea that I was going to make. The idea took 5 minutes to think about, and getting it done took 4 to 6 hours. First, I made a manager for those rotation speeds and so on, but I'm not making much use of its features, but it's there now. I thought that if you can make a cylinder, right, and in an earlier example, I drew a triangle, and it had different colors. I could make a cylinder of a single color that's thin. Let's see, this is quite thick, its thickness is 1, in fact, right? 1 unit. And you saw how thick that is. So I thought I could make a thinner cylinder. Instead of using 1 and -1, use a bigger number. So those triangles are great big long triangles. And I would essentially be able to draw a line, like a straw almost. And then I could do that in such a way, like this here, this one is aligned with the y-axis, right? That's certain of that, because x and z are not constant, but y is changing. The same, not the same. It has symmetry about the y-axis, right? The distance from the y-axis to any point in one of these triangles is the same. Perpendicular distance. So therefore this cylinder lies along the y-axis. So then I came up with first I had to create a new type of vertex type. And what took forever was I finally realized, because I couldn't get them to paint right, that I needed to make a vertex buffer for every triangle strip. Okay, so I need 3. I need one for the x axis, one for the y-axis, and one for the z-axis. And each one is going to be a similar thing, right? And I want each one to have a different color. And here, this layout 1, layout 2 is just like this thing, 1 plus and 1 minus, and putting the cosines and thetas in the correct positions for the various coordinates. 0 is the x-axis, 1 is the y-axis, so I would expect that the y-axis will appear green, and we don't know about x and z. Well, here's what I got, eventually. I wouldn't be doing this if I didn't finally get it working. Alright. The y-axis is indeed a green bar. Now, whether or not this is x and this is z, we don't know. We can stop it. And I have a reset all angles. Okay. Now remember that the way we'd set this up was that we were staring at the origin from a position out here in the background, with up, our up being in the positive y direction, which would be normally this way, down, right? So therefore we are upside down, looking this way at a cylinder that is, as you can see quite clearly, surrounding the y-axis. I have a rotation about y set. So if I just started, it's rotating about y. Now let's stop that again. Reset. Now red has got to be the z-axis. Okay. Coming out of the page. So if I rotate about z, you can see it's not moving, it's not changing, and x and y are changing. This cylinder itself in the world, these are the transformations that are being done are called world transformations. So the world X, Y, Z is being rotated one way or another. But the object itself, as you can see, is not changing its world position. It's still in the same position. Okay, stop that. Now let's go back to the beginning. If I rotate, suppose I rotate a bit about Y here. Okay, and then, well, first let's just do X. Here's X. Okay, that's the X axis. So rotation about X is what you'd expect. So I want to do a rotation about Y slightly, and then I'm going to rotate. Now the Y-axis is still pointing the same way it was, right? But now I want to introduce a rotation about this axis. So it's going to continue. Our view is going to be so that there's a rotation about this axis and this axis. Okay. Now, is it really doing that? Well, it's difficult to tell. Certainly, the Y, our world view is supposed to be rotating about X and Y. And you almost can't, pretty much you can't tell, right? You can reset all the angles. So now here we are in a situation where I've said I turned off the X rotation and now it's rotating about Y. But this is the Y-axis here, right? So to rotate about that axis is to rotate about an already rotated axis. Okay, stop that. It's a little bit too crazy. One of the other crazy things is, okay, you rotate a little bit about one axis. And then you start a rotation about another, just a different axis. And that, oh, actually that works out pretty good. That certainly looks like a rotation about the y-axis. How about X? Why wouldn't X work? Just X, which is this one, right? So it does work, okay. How about just Z? It should rotate about that. Z is red. But it's not. Unless I might have a bug. Z is No, Z's blue, right? I forget. No, X is blue, Z is red. It's definitely rotating on Z now. It could be the way I'm computing it. Why? That works. X. X, no problem. X is blue, yeah. Z, red. Doesn't seem to work. It might be because it definitely looks like it's rotating about. Oh, yes, well that's the problem. Any rotations about Z are a problem because our view is not perpendicular to Z. See, Z is not flat like X and Y are flat. So when we rotate this world about Z, no matter what, even if it's from this position, although it looks good, it's not this is getting bigger and smaller as it goes around, see? Because we're not looking straight at it. If we rotate about any other axis and then start doing a Z rotation, we get weirdo stuff. And you might know something about this if you've ever been to the fair. That if they have this, usually there's a ride you can go on, and that it works using this principle that rotation about two axes is a little bit convoluted, as you can see, right? If you add if you add rotation even at the same rate around the other axis, then you get a kind of chaotic rotation. Like sometimes it'll just go crazy and spin quickly in one direction and stop and zip back. I just add the last axis and watch what happens. You see, it did a really quick spin for no reason, and it's backing up and going forward, and that's just one of the principles of the way that rotations combine with each other. Is if you have rotation along all axes, you get a kind of a jerky, unpredictable motion. And that's supposed to be fun. Supposed to be fun. Now I can change the speed. All I can do is just stop one of these for a minute. Start it up again. See if I can get a weirder. See how it seems like it kind of was falling down or something for a while. It doesn't seem to have a cycle, but it must. In this case, they're all going the same speed. With my fancy thing, though, I can change that. I can give them different speeds. Now this is in units of degrees and hundredths of a degree. So let's let the x-axis be a little bit more. So that's 1.5 degrees per go. And is that one will maybe less? I don't know. See what happens. Oh, that's got to apply to both. I haven't done this with a lot of thought. As to finding a good mechanism for specifying these things. That. Is that right? Y, Z, X, N. So I can use floats too. I should probably use float doing radians. Then run. God darn it. Oh, it's building. Okay, so now they have different rates. I think all I gotta do is just put them all in, and we should get some pretty chaotic behavior. It's because they're not synchronized. That's not too bad. It's hard to tell. You don't know what it's going to do, right? But notice again, this object, as far as its world position is concerned, it's not changing at all. Only our viewpoint is changing. So like, why did it do that all of a sudden? Anyway, so I have a better clue. I have more of an understanding now as to what's going on with this stuff. As for the textures, that's weird. If I open a certain graphics, if it's got a lot of, it's probably just because I don't understand what I'm supposed to do. See how all the axes change the color to black? It seems to be or it may run out of colors, or I might just have some kind of bug. Graphics that have lots of colors in them enough colors anyway. Maybe it's using a palette. Those files are JPEGs, they're not paletted. And another weird thing I found with this was this picture. This one. Now, you'll notice, okay, that it's upside down. But other pictures when I load them in are not upside down. So why is this one upside down? It's a PNG too. That could be part of it. Let's see now. Sort Q Santa Claus. See that? I got some black. Well, Santa Claus is right side up. That's a JPEG. I think it's PNG. Yeah, that's upside down. It seems to load PNGs upside down. Bitmaps would probably be the same if I had one. There's something about these colors. It's got to be a paletted something or other. Anyway, I'm quite happy with the fact that I was able to draw the axes. In order to see them, I need color. See the colors? They're not the same, but they're definitely colorized. It's taking the colors sort of from a palette. It has to be a palette. It's probably creating a palette. And turn that off. Can you connect it upside down? No. Anyway, so there you go. And so now this distance from here to here is 1. If I want, what I should do is add a new thing that's not at the origin, and see, that it'll maintain its position in world space, and that might make it easier to see what's going on. Also, these are not anti-alias. You can make this anti-alias and a bunch of other stuff. Okay, see you.